In this video, I'm going to look at implementing Dijkstra's algorithm. I'm going to have a particular emphasis on how to maintain your accuracy in the exam. It's such an important consideration when doing any D1 question. So let's begin. We are finding the shortest distance from A to H. Now we can't really do anything at the moment because we don't have the trivial vertex in the solution, but because we're starting at A, we indicate that we can get to A with a distance of 0 because that's where we're starting. So A is the first vertex to enter my solution. Okay, but you do need to mark that up like that. I think putting 0 here is optional. It's not actually required. Now that A is in the solution, we can connect to two other vertices, B and D, and you must put the temporary working values here and here. Even though we can clearly see that B is going to be the second one to go into our solution, it's essential you do put in those working values. Now that B has just entered the solution, keep your focus there and think of the other vertices that you can now connect to. Okay, we can go to there and we can go to C, and we must now work out the working values for F and C. So let's look at C here. 124 add 100, 224, that will be 219. And we can get to F in, well, we've got 200, 260, add 11, 271. Now, I've acted on those two new vertices which I could connect, so I've done the job there. I need to take a step back, and I'm really just looking at those three numbers, and I of course pick the lowest. So now D permanently goes in there. That's 125, and again focus in on D. There's two things we're going to need to look at. We can get to C via an alternative route, and we can get to E for the first time. Now looking at C here, there is actually an improvement to go via D. We can get to C now in 199, and E for the first time we can get there in 192. Now I've done both. I've actually done both of those things from D, so now I take a step back again and I look at these three numbers, and I'm looking at the lowest number, which is of course the 192. So E is going to be the fourth one to go into the solution, and I permanently mark it up as 192. By the way, when you permanently put a value in, what Dijkstra's algorithm is saying is, for example, to get to E, the shortest way you can get to E is 192. So that's always true as you go along. As soon as that permanent value goes in, Dijkstra's algorithm has worked out the shortest way to actually get to that vertex from wherever you started. Oh, well, where was I? I've just added E, that's the fourth one. So again, your attention's going there, and you've got to think of all the implications. We can get to F via a different route, we can get to G for the first time, and we can even go backwards to C. You don't have to go forwards. Sometimes you'll be going backwards, you know, and sometimes you just go up or down. It's not always just forwards. But anyway, going backwards is not helpful, because that gives us 192 at 101, which is not going to be an improvement. But let's look at F. We're now 192, add 75, that is going to be an improvement. We can now get to F in 267. And G, for the first time, we can get there in 192, add the 8, we're on 200, so we can get there in 270. So I've acted on all those three possibilities from E, so now I take a step back again, and I'm looking at that number, and that number, and picking the lowest, which is C, and that will be the fifth one to be added there. So the quickest way to get to C is 199. Think of the implications, because you just added that. We've got implications there, and there, and none of them actually matter because they are all going to vertices that now have a permanent label. So it doesn't matter. We're only going to consider vertices that do not yet have a permanent label, the ones that have temporary labels. So nothing to do with regards to C being entered. We're just going to look over here for the lowest number. So F is next in line to be added, and that gets added there. Now there are implications. We can get to G a different way, and we can get to H, our final destination, for the first time. We can get to H in 300, 377, 385. And let's also look at this F to G, and that's not going to be an improvement quite clearly. So we now take a step back. We've done our job with regards to F. We look at the smallest number. Of course it's 270, so that's the seventh one to be added. We put in the 270 there, and there's really only one vertex that has temporary labels on there that's not been permanently added yet, and that's H. So we look at that, and if you add 270, 130, we're on 400, so that's going to be 405, so that's not going to be an improvement. So 385 will be the answer. Let's just label that up there. That is expected. So 385 is the shortest length. Now, it's not trivial to actually work out the shortest path, though. We need to be quite careful in going backwards. And also using memory, if you recall, we didn't go that way. That was given as the 405. The shortest path must be this way. And the reason is, if you take 385 and you minus 118, that does give you 267. Now if you take 267 and you minus 75, that does give you 192. So we know to go down there. And if you take the 192, you minus off 67, that does give you 125. So you know that the shortest path goes down there. And if you take 125 minus 125, of course you get 0. When it comes to writing the shortest path, you see a lot of people doing like arrows and things like that. It's not needed. Just write it as A, D, E, F, H. It's really that simple. It's not so simple when you get this type of question. Here's just what I made earlier. It's the same as what we've got up there. When you get asked this question, explain how you determine the shortest path. And you can write it in words and just write a paragraph, but perhaps the best way to explain how we move backwards through this diagram is just to show them some arithmetical calculations that helped us. It's often what you see in Excel math schemes, and it's what I would recommend. So we started with the 385, and because when you minus 118, that lands you on 267, we could conclude that this edge was in our solution. So we could conclude that FH is in there. And now taking the 267 and minusing off 75, that gives us 192. That allows us to conclude that EF is in the solution there. So we can put that in and just keep going back like that. When we do 192 minus 67, we get 125. That allows us to conclude that DE is in there. And as trivial as it might seem, let's just put 125 minus 125 equals 0. Therefore, we knew that AD was in our solution. You can actually see your root as A, D, E, F, and H. That was our root there. So that's how I'd recommend you to actually explain your shortest path. I think that is acceptable if you look at the mark schemes, and you know you should get all the marks that way.